Hello, welcome back to my GCSE Science. In this video on using resources, we're going to be talking about how different types of materials are used in everyday life and how their properties are related to their uses. First of all, let's look at alloys. We covered alloys a bit already in the earlier video on metallic bonding, but let's just recap the main points here. On the left-hand side, we've got the structure of a pure metal, which is a giant lattice of positive metal ions that are held together by a sea of delocalized electrons. This structure makes metals quite malleable, which means they can be shaped quite easily without breaking, but that also means that they're often softer than needed for a particular purpose. So a lot of metals that we use in everyday life are actually alloys, and you may remember that an alloy is a mixture of a metal and another substance. The other substance may be another metal, or it could be another element, normally carbon. So here on the right-hand side we've got the structure of an alloy. It's got the same metallic bonds where the ions are held together by the sea of delocalized electrons, but because there are atoms of a different element that are bonded within the structure, they disrupt the regular layers you would normally find in a pure metal. And in general this makes metals stronger and harder because the layers of ions can't slide past each other as easily. In the exam you may be expected to identify some examples of alloys and relate them to their uses. So here are a few common ones. Bronze and brass are alloys of copper. Bronze is alloyed with tin, and it was the first alloy ever made about 5,000 years ago. It's really tough and resistant to corrosion. Brass is an alloy of copper and zinc. It's harder than copper, but it's workable into intricate shapes, and this allows it to be used for small decorative items, and it's also what's used to make brass musical instruments. There are lots of different aluminium alloys out there, where aluminium is alloyed with various different materials to get different types of properties. But all aluminium alloys have a low density, and that's the key thing. The aluminium part of the alloy makes them lightweight, but alloying it with other materials generally makes the material stronger. You might not realise it, but most gold is also an alloy. It's only 24 karat gold that's 99% pure. Most gold is alloyed with copper, zinc or silver in different amounts to get different results. In general, this is done to make gold harder, or sometimes to change its colour, so you get different shades of gold. For example, 12 karat gold contains only 50% gold and 50% other metals. And you might have heard of things like rose gold and white gold, which are different shades of gold created by mixing gold with different metals. Another really important type of alloy are steels, which are alloys of iron that contain specific amounts of other elements in them to produce specific properties. High carbon steel contains about 1 to 5% of carbon, and most of this already exists in the iron that comes out of a blast furnace, which is how most iron is made. High carbon steel is very hard, but it's also very brittle. Low carbon steel, which is made by removing some of the carbon from the raw iron that comes from a blast furnace, is softer and less brittle and therefore more easily shaped. And it's important that you're able to compare high carbon steel with low carbon steel in terms of how carbon affects its hardness and brittleness. Stainless steel is a type of steel where the iron is mixed with other metals, such as nickel or chromium. This makes the steel harder, shinier, and most importantly, resistant to corrosion, which is what makes it so useful for cutlery. So remember that most metals are actually alloys, and the exact composition of the alloy affects the metal's properties. Now let's look at some non-metal materials and their uses. Here we've got glass and ceramics. They're both quite common materials in our everyday life, and they're both quite hard and quite brittle. You may already know that glass is made from mainly sand, which is silicon dioxide. Common glass is actually called soda-lime glass, where the silicon dioxide is mixed with sodium carbonate and limestone. But if you want to produce glass that's harder and that has a higher melting point, then it's mixed with boron trioxide instead, creating borosilicate glass. This is used to make glass that's intended for things like oven cooking, or test tubes even. To make glass, the mixture of sand and other chemicals is heated to about 1500 degrees centigrade to melt them all up and mix them together. Then the glass is shaped as it cools, and as you can see here in the diagram, it forms an irregular structure. In many ways, ceramics are similar to glass, the main difference being that glass is transparent and ceramics aren't. Ceramics are normally made from clay, and this includes things like bricks, crockery, like your bowls and plates, baths, sinks, toilets, and tiles. To make ceramics, the clay is moulded into shape when it's wet, and then it's heated to a high temperature in a furnace to set the objects into their final shapes. The properties of ceramics come from their unique structure. Clay is made up of a mixture of compounds that contain both ionic and covalent bonds, and when it goes from wet to dry in the furnace, a regular crystalline structure is produced, where the atoms and compounds are held together by strong bonds throughout the ceramic. This structure makes it really hard, but also quite brittle, meaning that it can crack easily. This is because if a force is applied to the structure, the ions get dislodged, and rather than the oppositely charged ions attracting each other, as the atoms get shifted, similarly charged ions start to repel each other, and this can cause a crack that goes throughout the substance. Ceramics are also useful as most of them are electrical insulators, and they are very resistant to corrosion. With a lot of materials, including glass and ceramics, we don't have to stop at the properties that are produced just from each one by themselves. A lot of materials these days are composites, which, like formulations, are made of a mixture of substance that together provide properties that each single substance doesn't provide by itself. In a composite, fragments of one material are usually bound together by the other, and this combines the beneficial properties of both materials. Here are some examples. As we said, both glass and ceramic are hard but brittle. But if we make a composite of glass ceramic, this produces a hard but much tougher material, and this is because the glass melts between the layers of ceramic, which prevents it from the cracking we talked about earlier. Fiberglass is a composite of glass and polymers. This gives it the toughness of glass, but the flexibility of polymers. It's also waterproof and low density, so fiberglass is often used for things like kayaks and sailboats, and it can be used for strengthening sports equipment that also needs to be light. This is just one type of example of a polymer composite, but there are many more useful applications for this type of composite, such as ceramic polymer composites and carbon polymer composites, which can even be made to conduct electricity. There are also composites made of wood. Plywood is made of thin sheets of wood that are glued together so that each layer has the grain going in a different direction, and this prevents the wood from splitting along the grain. In MDF, wood chips, shavings or sawdust are bound together by a polymer resin, and this makes a strong wood-like material, but it allows shapes to be cut without splintering. Concrete is another example of a composite material. In concrete, we've got cement, sand and gravel that are mixed together with water. It's left to dry, and as the water leaves the mixture, it sets into shape and becomes very hard. The more it dries, the harder it becomes. As such, concrete is a very strong material, and you can make it even stronger by reinforcing it with steel rods, where the wet concrete is formed around steel rods and then left to set around the steel, and this makes the concrete much more resistant to bending forces. This hardness and strength makes concrete particularly useful for building materials. Finally, let's look at some properties of polymers. In the organic topic, we looked at how polymers are made and some of their uses. But you also need to know that you can change the properties of polymers, depending on what monomers are used to make it and the conditions that are used to carry out the polymerization. Here are a couple of examples that you're expected to be aware of. Here we've got two types of polyethene. Both are made from the same monomer, ethene, but they're made under different conditions. The first one, low-density polyethene, is made under high pressure in the presence of a little bit of oxygen, and it creates branched chains, which means that the molecules can't line up and pack closely together, making it low density. This kind of polyethene is what you find in plastic bags. But if we change the conditions, high-density polyethene can be made instead, using a catalyst, a slightly increased temperature, and a slightly higher pressure. This produces straighter chains, which are able to pack much closer together, creating strong forces between the molecules, making the material not only higher in density, but also harder, and giving it a higher softening temperature. An example of a use for high-density polyethene are milk bottles. So both plastic bags and milk bottles are both made from the same monomers and are both polyethylene. But by doing the polymerization reaction under different conditions, we can create quite different types of materials. You also need to know about the difference between thermosoftening polymers and thermosetting polymers. Thermosoftening polymers melt when heated, and this is because the polymer chains are easy to separate because they have weak intermolecular forces that hold the chains together. But thermosetting polymers don't melt when heated, and this is because there are strong covalent bonds called crosslinks which hold the polymer chains together. This makes thermosetting polymers very, very heat resistant, making them useful for the plastics used for plug sockets in the walls, for example. So that was a bit of a whistle-stop tour to a variety of different materials and their uses. But the key thing is to be able to link the structure of the materials to their properties and their uses. If you've got any questions, feel free to contact us using the links below. Thanks very much for listening, and see you again soon on the next video by My GCSE Science.